This video is about graphing techniques for functions. You've already been introduced to the basic curves, the basic functions, and what their shapes are, what we call them. So in this video, we're going to talk about ways of moving them around in the coordinate plane, and getting the correct graph for each function. So just quickly sketch and review 4 of the basic curves that we've previously talked about. So I have myself a coordinate plane here, the y-axis and the x-axis. And the curve y equals x squared, or f of x equals x squared, we know is the parabola with the vertex at the origin. We know it's the basic U shape, symmetric with respect to the y-axis. The cubic function, y equals x cubed, we know is the Superman curve. We go up and away on the right side. It comes through the origin and goes down on the left side. The square root function we know is the upper portion of a sideways parabola. It's kind of the best way to explain it. We could not put any negative numbers in our domain, so we start at 0 and then it goes forever to the right. So that's the square root function. And hopefully you have memorized these and what they look like. Lastly, we have the absolute value function. If you remember, it is the V shape with vertex at the origin. Perfect V shape bisecting quadrants 1 and 2, making a perfect right angle. That don't look too perfect, but you get an idea of what you're looking for there. That's what the basic shapes of the basic curves do. Now, if I mathematically add or subtract numbers or multiply numbers to these functions, it changes the shapes in different ways. Let's look at a summary of what will happen. In the descriptions that follow, assume that a is a number greater than 0, h is a number greater than 0, and that k is greater than 0 in comparison with the graph of y equals f of x. If I just add a constant number to a function, it's going to move it up. If I subtract a constant number from a function, it's going to shift everything, or translate means to slide. It's going to shift it all down k units. If you have parentheses or grouping symbols and there's been a number added to the x in parentheses or in grouping symbols, you're going to do these two opposite what you would think. If it's a plus sign, you actually are going to translate the whole graph units to the left. If it's a plus, you're going to go to the left. If it's a minus, you're going to go to the right. So on the horizontal shifting, you're going to do opposite of what you would possibly think there. Okay? If I multiply a number times a function, it's going to stretch it vertically. If your a value, the number in front, is something greater than 1, it's going to make it grow more rapidly and stretch it vertically. Now, if the number in front of the function happens to be a fraction, a number that falls between 0 and 1, it's going to shrink it. Instead of stretching it vertically, it's going to shrink it. It's going to make it open fatter. It's going to make it wider. The stretching vertically up is going to make it more narrow. The graph of a times f of x is a horizontal stretching if it is between 0 and 1. So again, that means it's going to make it out wider, stretch it out wider. If the value of a is greater than 1, it's going to make it more narrow. If it's a fraction, it's going to make it more wide. If you negate the entire function, it's going to flip it across the x-axis. If you negate just the x inside, it's going to flip it across the y-axis. So I know that's a lot of information, but let's just kind of see it in practice. That may help you understand what's going on a little bit better. You may have to memorize some of this information. So if I want to sketch the graph of x cubed minus 1, well, I know the original graph. I'm going to plot the original graph in blue just so we get an idea of what this looks like. Your cubic function, x cubed, if I put 0 in there, you're going to get 0. So we know that's the Superman curve. 1 cubed is 1. 2 cubed is 8, which I can't even fit on this graph. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So this thing's going down this way and then up this way. Now that's just your basic curve x cubed. The fact that we're subtracting 1 from the entire function, this is going to shift the graph down 1 unit. All the points from your original curve are going to move down 1. So the points I've got plotted here, I'm going to actually just shift them all down 1 unit. So I'm going to even erase the blue. And now my new graph is okay. So the basic curve x cubed has just all been shifted down 1. Now I could use a t-chart as well if I wanted to and plug points in and see what I would get and just plot those out. But you kind of need to have a basic understanding of what the original basic curve would look like before you even start on a problem like this. Let's do another one. F of x equals the absolute value of x plus 2 minus 3. So as you can tell, we're dealing with the absolute value graph. Before we even get started with trying to graph this one, let's think about what the absolute value graph looks like. Okay, absolute value of x we know is a V shape. Let's graph that. The absolute value of 0 is 0, so 0, 0. The absolute value of 1 is 1, so 1, 1, 2, 2. The absolute value of negative 1 is 1, so notice your V shape that you're going to have here. If you remember from your previous lessons, that's the absolute value graph. Now, in this one, we've got some shifting going on. We've got x plus 2, so we're going to be, it's grouped in the parentheses or in the brackets here in the absolute value bars with the x. Since that's grouped in, that's going to be a horizontal shifting. Then you have minus 3. 3 is being subtracted from the entire function. So that's going to move us 3 units down. And since this is a plus inside with the x, we're going to do to the left. So what I'm going to do to plot my new graph is all the points that I originally have, I am going to move all those points to the left 2 units and then down 3 units. Let's start with the vertex. To the left 2, so 1, 2, and then down 3. 1, 2, 3. That's going to put my vertex at the point negative 2, negative 3. There's the new vertex graph. So actually, I could just erase this basic curve and now plot my new curve. I know where my new vertex is going to be. There you go. That's the translated graph. Now again, if I wanted to just plot points, I could. If I picked negative 1, if we plug negative 1 in here, we'd get negative 1 plus 2, which is 1. The absolute value of 1 is 1. 1 minus 3 is the point negative 2. So we would be able to plot this with a t-chart as well. But I like you to see the translations as they take place in the equation. The square root function, square root of x plus 1 and then minus 2. If you'll notice in this one, the x plus 1 is all under the radical, so this is grouped with the x, and then the minus 2 is not under the radical, so this is just 2 being subtracted from the entire function. Now before we try to do this graph, let's talk about the basic curve. We know the square root function started at 0 because we can't have any negative x values. The square root of 1 is 1, so we had the point 1, 1. The square root of 4 was 2, so we have the point 4, 2. So this was your basic curve that we start off with. Now, according to this new function they want us to graph, we're going to do some shifting here. So we know that the plus 1 that's grouped in with the x is a horizontal shift. That'll be to the left. So to the left 1 unit. And then the minus 2 on the outside, that means we're going to shift down 2. So all the points that you've got originally are going to shift down 2 and to the left 1. So let's start with this point. Down 2 and to the left 1. So that's going to make it be at the point -1, -2. Down 2 to the left 1, down 2 to the left 1. So this is my new graph right here. I can actually get rid of this other blue stuff. This is the graph we're looking for. Notice if I pick the x value as being 3, 3 plus 1 is 4. The square root of 4 is 2. 2 minus 2 would be 0. So there's the point 30. A T-chart will also get you through this problem. F of x equals -x cubed plus 1. So obviously in this problem we're talking about the basic curve, the cube, the Superman curve. So let me just give you an idea of what that would look like first before we try to actually graph this. We know the x cubed goes through the origin. You go up 1. 2 to the third power would be 8, so it's going to go up. We go through the point -1, -1. And it goes down. We know that's the basic curve. Now, if we think about this, with this time we have it negated. If we have a number, if we put a negative sign in front of the entire function, it flips it across the x-axis. So what happens here is we're going to reflect. This side is going up, so now it's going to be going down. This side is going down, so on this side it's going to be going up. So actually, this is what we're going to look at. Instead this time. So let's erase our original. Okay, so that's the negated function. And also, so let's write it, we're going to flip across the x-axis here when the function has been negated. And then the plus 1, we know that's going to shift everything up 1. So let's move all of our points up 1 unit. So I'm going to, using red, we're going to move everything up 1. So I can now take away that blue stuff. And here is our curve. Okay. So the negative there is going to flip it across the x-axis. Make sure you understand that reflection that's going to take place. Okay. In this problem, we have the absolute value graph. So everybody remembers that one is the V shape. So I'm going to just plot that real quick to kind of give you an idea of what that looks like. That's the normal absolute value curve right there. But in this problem, we've got 3 things going on. First of all, the negation out front means we're going to flip that. So the flipped V would look like, it's flipped across the x-axis, would be like so. So let's take away that original to get that out of the way so you'll get that confused. So that's going to be my flipping part right there across the x-axis. Okay. Grouped inside with the x, we have the plus 2. So remember, we're going to do the opposite of what we think. So that's going to be a shift to the left 2. And then the minus 1 being subtracted from the entire function is going to be a shift downward of 1 unit. So the points I've got here, I'm going to shift those down 1 and to the left 2. So let's start with the vertex point. Down 1 to the left 2. So my new vertex is at the point -2, -1. So I'm actually going to erase that old stuff out. Now that we know where our new vertex is, we can just graph the function